Oh, caught in a bad problem. Ha ha, hoo ha ha. Problem 5, Unit 18. That's what we're doing right now. All right, here is our tough problem of the day. It is Problem 5, Unit 18, Acids and Bases. And these are the answers here, but we're going to go through these and talk about how I would do this problem. Well, first let me give you an example of these Bronsted-Lowry pairs, these conjugate acid, acid conjugate base, base conjugate acid pairs. So let's just take a look at this equation. And we end up with hydronium ion here and a chlorine ion. Now, when we do these, which is the acid here? This one. It's donating the hydrogen. Okay, that makes this one, we'll color a different color. This is going to be the base. All right, well, what did this become? Well, this became this. The acid now became the conjugate base, because if you go the other way, this is going to accept the hydrogen, the H+, conjugate base. So if you look at it in this direction, this is the acid, this is the base, boom. Right here, this is the base, this became the acid, but we call it the conjugate acid, okay? So there's the pairs, these Bronsted-Lowry pairs. So you have the base, conjugate acid, acid, conjugate base, because if you're going this way, okay, acid becomes the base, this is the base, becomes the acid. If you're going the other way, okay, this is the base, this is the acid, and they become back and forth. So these things, this reaction is reversible, goes two different ways. And that's all we'll talk about that for right now. But consider this, all right? Now, let's go to the problem. Okay, the first one says the conjugate base of this. Well, of this, so this is the conjugate base, and that means this has to be the acid. Okay, in order for this to be true then, the acid has to donate an H+, and then become the conjugate base. So did this lose an H+? Well, the H is gone, and it was -1 and then became -2. So if you subtract a +1, it should become -2. Perfect. That's why this one is true. Let's go to the next one. The conjugate base of this. So once again, this is the acid. I'll put an A here for acid. And then this has to be the conjugate base. Okay. So, does this lose a single hydrogen? No, it lost 2. So it's tricky. No, it loses it one at a time. So this is false because it lost 2 hydrogens. It has to lose exactly 1 H+ ion. Okay. Ooh, they're getting tricky now. They say this, what is the conjugate acid of this? So this has to be the base. Sorry, the writing's a little small. And then this is the conjugate acid. Okay, the base has to gain an H+. The others were losing an H+. This has to gain an H+. Oh, it did gain an H. Did it add, and did we add a +1? Well, a -2 became a -1. Boom, shakalaka. Old NBA Jam lingo, if you remember that from the old Nintendo days. 3-on-3 basketball, and then the nets would, he's heating up when you hit 2 in a row. And if you hit 3 in a row, he's on fire. So, good classic game. Shout out to my buddy Chad Naraka, who I always used to play with that game with. All right, so here we go. Conjugate base of this. Okay, so that means that this is the acid, and this would be the conjugate base. All right, the acid donates an H+. Did it? Yeah, it lost a hydrogen, and it was neutral, then became a -1, so you subtracted a +1. Yeah, good. Check. All right. The conjugate acid of this. So this is the base. This is the conjugate acid. To go from a base to a conjugate acid, you have to add a hydrogen plus. Did we? No. We actually lost one, so that's why this one is false. Okay, the conjugate base of this. So what is this again? This is the acid. And what is this? This is the conjugate base. Okay, so to go from an acid to a conjugate base, we have to lose an H plus. Did we lose an H plus? No, we actually gained an H, so false it is. And there it is. You have this problem to look at, and if you get in question, go back and think about this, and you got a little entertainment out of it. So have a wonderful day. It's beautiful out there right now.